Most of you all know what finding a number square is. So if I said find this, what 4 squared is, you would be able to tell me that 4 times 4 equals 16. Okay? However, if you take the inverse of the square root of 16, you would be telling me that the square root of 16 is 4, because squaring a number makes it bigger, taking its square root makes it smaller. Same thing, the inverse of cubing a number, so multiplying it by itself 3 times, is taking the cubed root. So now let's practice some of these. Alright, so on our first example, you'll notice that we have a negative sign on the outside of our radical symbol. Okay, that negative has to stay with your answer. Well, the square root of 25, if you do it in your calculator, you'll get the answer, is simply 5. We brought down our negative, so the answer is negative 5. In your calculator, if you do the square root of 144, you will see that that equals 12. The square root of 64 is 8. Okay, on our second column, we're doing cubed roots. Okay, so again, if you put the cubed root of 125 in your calculator, you get that it equals 5. The cubed root of 64 is 4, and the cubed root of 1000 is 10. So this slide was just calculator work. So our last slide was simply calculator work. However, there are going to be times when the calculator will not do the work for you. It'll give you a decimal. If you don't get a whole number for your answer, then we need to talk about how to simplify radical expressions that aren't perfect squares. The first thing you'll need to do are find the factors of the number under the radical that are perfect squares. Okay? Second thing, again, is just finding the perfect square factor. And third, we're going to keep the non-perfect square factor underneath of the radical. Okay? So let's look at the square root of 63. So there are many factors of 63. However, the factors that we are looking for are 7 and 9. Okay? Once you've gotten that, you need to put them both under their own radical sign. Well, 9 is a perfect square. The square root of 9 is 3. However, the square root of 7 is not a perfect square, so we're going to just keep that under its radical and multiply it by the 3. So your final answer is 3 times the square root of 7. With 20, 4 times 5 gives us 20, and 4 is a perfect square. So when we take the square root of 4, we get 2, and we keep times the square root of 5. So let's do a few more examples on the next page. Okay, so if you remember back to our PowerPoint on factoring, we gave you a list of all of the perfect squares, including perfect squares for variables. Okay? That doesn't change when we have more complex numbers. Okay? When we have the square root of 36x squared, you take the square root of 36, which is 6, And the square root of x squared is x. So your answer here is simply 6x. For the one below that, the square root of 9 is 3. And the square root of z to the fourth is z squared. Okay? The square root of 81 is 9. The square root of x to the fourth is x squared. And the square root of 25 is 5. The square root of a squared is a. And we do not have a square root for b, so we keep that under the radical sign.